So in this lab, you're going to take steel wool and you're going to rust it. Steel wool is often covered with oils to keep air from contact. And so first what you're going to do is you're going to wash it with a little bit of soap. Now, once it's dry, you want to weigh the steel wool. You're going to weigh it with an analytical balance. For best results, you want to weigh this as soon as it's dry. So this is the analytical balance. It weighs to 3 decimal points. It's a very special balance. You see it has a cage around it because even air currents will change the mass of something. It's that precise. This will be out in front of the office, in front of the school, because I think for best results you should use this balance. I'm going to push the on button. Make sure it says 0. You're going to slide open one of the doors and gently place your steel wool on the tray and record what it says. You also want to know how much a coffee filter weighs. If you don't have one, there'll be some by the scale. Make sure to close the door after you've placed it on. And just for transportation fact, you might also want to have a plastic baggie and know how much that weighs. You want the whole thing on the scale, none of it touching the surrounding sides or else it will mess up your value. Once you have those, please press the off button. So if you can't make it to school to measure your steel wool, then I would suggest you use your scale from at the beginning of the school year. You might not get enough significant digits to make a difference, but it's worth a try. In that case, you wouldn't have to measure the baggie because there's no transportation needed. Just measure the steel wool and the coffee filter. Then take a plastic bottle and cut the top off like this. Make sure the lid's on it. You're going to place your coffee filter into the bottle top. Add your steel wool into the coffee filter. And then we're going to soak it with hydrogen peroxide. This is hydrogen peroxide from the store. If you don't have hydrogen peroxide, you can try vinegar. I don't know that it'll work as well, but you can try it. If you don't have vinegar, you can just try boiling water. To whatever you decide to use, also add a pinch of salt. The salt is just a catalyst that helps the reaction occur. Then set this aside where it's not going to get knocked over and just let it set for a day. This is the end of day 1. So this is day 2. Should look pretty rusty in there. So what you're going to do today is you're going to stir the stuff up. You can either swirl it like this, or you can stir it with a stir rod. Look to see if things are still reacting in there. And then add a little bit more vinegar or hydrogen peroxide, depending on what you are adding. You're going to add a little bit more. You might want to rinse off your stir stick with that so that you're not taking away any particles. You want to leave all the particles there. Give it a little stir and let it set for another day. So day 3, you're going to take your rusty steel wool. You're going to remove the lid and drain the hydrogen peroxide or vinegar, whatever you used in there. Drain that all out. Then you're going to use your pipette and just rinse the precipitate inside. You're trying to rinse away all of the salt, the leftover vinegar. You're trying to rinse all of that away so that all you have inside is just the rusty precipitate. As soon as that's all drained, you're going to take the filter and lay it out flat. I'm going to put it on this watch glass right here. You can put it maybe on a paper plate or something like that. You want to put it out so that it can dry. Let it dry overnight. That's the end of day 3. Okay, day 4. Now that your rusty coffee filter is all dry, you're going to mass it one more time. So you're going to turn it on, make sure that it's at 0, open the little window, and take the final mass. If you had to transport it inside of a baggie, then I would just leave it inside of the baggie. That's why you got that mass at the very beginning. Once you've recorded all your masses, this is now garbage. You can throw it away. So that's the end of day 4. Now you can crunch your numbers. Okay, let me help you with some of the math. This math should not be on yours. This is my math. You should do your own math. But I just want to show you how to do some of these things. First, was the mass of the coffee filter? 0.886 grams. The mass of the filter and the steel wool? 1.580 grams. And the mass of the dried filter paper and the rest, that was on day 4. You should also write your observations. All right, for calculations, what was the mass of the iron? Well, you take data item 2 and you subtract data item 1. The mass of my iron. How about the mass of the rust? Well, you take data item 3 minus data item 1. How about the mass of the oxygen? Mass of the oxygen is what was added. That's the extra mass. So, was the mass of the rust minus the mass of the iron is the number of grams of oxygen. Next, how do we convert to moles of iron and moles of oxygen? Well, we have grams. Here we have grams of iron from up here. And I know for every mole of iron, it weighs 55.85 grams. I found that on the periodic table. Those grams of iron cancel out, and I'm left with 0.0124 moles of iron. And then you do the same for moles of oxygen. Here I have my oxygen. And I know that there's 16.00 grams of oxygen for every mole of oxygen. So that gives me 0.00463 moles of oxygen. All right, so next I'm going to try and find the empirical formula. In order to do that, I need to divide both the moles of oxygen and the moles of iron by the smallest coefficient. So my moles of oxygen and my moles of iron, I'm just rewriting it. Which one is smaller? This one is smaller. So I'm going to divide both of them by the smallest one. Now, unfortunately, that ratio 1 to 2.68 is not within a very close of an integer. So I can't just round off. So what I'm going to do is I'm going to multiply both terms by the same number until a whole number for each is achieved. If I multiplied this by each of these by 2, it wouldn't work. It wouldn't give me a number that was a whole number down here. So I know that if I multiply each of them by 3, I would get a 3 on the top and I would get 8.04 on the bottom. Now that's pretty close to a whole number. So we have a 3 to an 8 ratio. That means this is oxygen, remember, and this is iron. That means for every iron, I have 8, and every oxygen, I have 3. That's the ratio that I'm coming up with. That's the experimentally derived ratio. All right, next let's do error analysis. How much iron oxide should have been produced? We're going to try and find the theoretical mass. I started with 0.694 grams of iron on day 1. That was a measured amount. From the periodic table, I know that 1 mole of iron weighs 55.85 grams. That will cancel out my grams. From the balanced equation, there's the balanced equation. I know that for every 2 moles of iron, I know that's 2, for every 2 moles of iron, I get 1 mole of iron 3 oxide. That's going to cancel out those moles there. Now I have moles of iron 3 oxide, and I'm trying to figure out how many grams I should have made. How much does each mole weigh? Well, yeah, calculator. 2 irons plus 3 oxygens. Each iron is 55.85. Each oxygen is 16. That gives me 159.70 grams of iron 2 oxide. If I had a mole of iron 2 oxide, it would weigh 159.70 grams. All right, so my units have all canceled out. I'm left with grams, which is what I want. That's my theoretical mass. Now I have to calculate what this weird number is. So I put into the calculator 0.694 divided by 55.85 divided by 2 times 159.7, and I get 0.992222. How many sig figs do I have? I've got 3 sig figs, so 992 grams, 0.992 grams of iron 3 oxide. That's how many I would have theoretically gotten. That's my theoretical number right here, 0.992 grams. Right? That's not how many I actually got. My experimental number is up here for number 2. My experimental mass, 0.768. There's my percent error, 22.5%. All right, so what are the results? My empirical formula I got up here, number 7, Fe8O3. Now, what's the name of that? Well, you can either make iron 2 oxide, which is FeO, or iron 3 oxide, which is Fe2O3. And I'd say that this ratio is closer to that one, right? What's your ratio closest to? And then my percent error is 22.5%, right? And it was negative. I lost mass. So why was that? That goes into your discussion. What about this? Where could I have lost mass? I saw rust on the drying plate. I knew that it went through the filter. Maybe I should have doubled up the filter, but that would have given me a negative percent error, which is what I got. If you used vinegar, you might have made iron acetate because vinegar is acetic acid. So instead of the iron grabbing onto the oxygen, maybe you made iron acetate, some version of that, which might have made it weigh more. This should be part of your discussion. Why was that percent error where it was? Where might you have lost or gained mass in this process? Now, do this with your own numbers. If you just couldn't get your own numbers, look in the description of this video for another set of numbers to use. Good luck.